1a. Nuclear fusion is a process that releases energy. Which of these statements applies to a nuclear fusion reaction? A. It emits daughter nuclei. B. It is controlled chain reaction. C. It produces radioactive waste. D. It requires higher temperature and pressure. And so the answer will be D. It requires higher temperature and pressure. Question 1b. In the sun, 4 protons start the process of nuclear fusion. These protons combine and finally use a helium nucleus. The helium nucleus has a smaller mass than the 4 protons. This difference in mass is converted to energy. 4 protons have a total mass of 6.69 times 10 to the power minus 27 kilogram. A helium nucleus has a mass of 6.64 times 10 to the power minus 27 kilogram. Calculate the percentage of the original mass that has been converted to energy. Let's identify the masses for 4 proton and that of helium nucleus as the mass. So we want change in mass, which equals to 4 of mass proton minus a mass of helium. And we populate it with the values. Now we've got common factor here, 10 to the power minus 27. So if I take it out, I get this. And then that gives 0.05 times 10 to the power minus 27 kilogram. Now I need to find the percentage. And the percentage will be the change in mass over the 4 mass of proton times 100. So that's the change in mass over the mass of 4 protons. The 10 to the power minus 27 cancel out, and then we get 0.05 over 6.69 times 100, and that is 0.747, rounded up to 0.75%. Question 1c. Figure 1, this one here, shows the spectrum of an element detected in the light from a distant galaxy, from a nearby galaxy, and from a source on Earth. This is a source on Earth, nearby galaxy, and from a distant galaxy. Now, estimate the difference between the wavelength of line P in the spectrum from the distant galaxy and the wavelength of the line P in the spectrum on Earth. So we need to look at the distant galaxy here, and on Earth we're looking at this line P here over there. So that point is less than 500. We're assuming it's 490, and this point here, so if I draw that line there to align to that, and that point at 560, so that point is 560. And what we need is to work out the difference between them, 560 minus 490, and that gives 70 nanometer. So we put 70 here, that's 70 nanometer. Part 2, scientists have discovered the light from almost all distant galaxies has spectral lines shifted towards the red end of the spectrum. Explain how red shift in light received from galaxy at different distance from the Earth supports the idea of the universe is expanding. Well, we can see that the wavelength increases, the spectral lines shift to the red, so that's increasing wavelength. Point number 2, this means galaxies are moving away from Earth. Point number 3, more distant galaxies moving away faster, and this support the idea of an expanding universe.